This is a demonstration of the CAT TailSitter with ArduPilot in RF8. The 3D model for this vehicle was created by Lorbass on the forums, and most of the parameters came from a TailSitter built by Palm 369, and the design of the TailSitter is based on Palm 369's real TailSitter. So what we've got here is a simple two-motor TailSitter. So we have elevon control like that, and we have two motors, left and right throttle, which means it can fly like a typical dual motor TailSitter. So I'm now going to put it into Q-hover mode and take off in Q-hover. So I'm just arming the motors. The motors are armed, and now we'll do a takeoff. All right, so there it is, hovering, and it's hovering with a throttle of about 55–58%, and you can see the current reading on the top right. Now that current reading, I believe that's actually per motor, so it's a little bit higher than expected. All right, so there's the TailSitter, and you can see that the yaw control is quite good. And it has quite good climb and descent rate. And I'll now do a bit of pitching. That's pitch forward, and that's pitch back. And now I'll roll it to the right, and roll it to the left. Now with these types of TailSitters, if you do roll or pitch too far, it can have trouble recovering again. So I'll just try that. So I'll tell it to roll hard right, and it can become rather unstable. And that, I think that could be a little improved with a little bit of gain tuning. It gets unstable fairly easily. Let's try it to the left. Another problem is that it's not doing speed scaling based on airspeed. So when it gains significant airspeed, it does have a lot of trouble maintaining good attitude stability, and that's something that we should definitely improve in future versions of the code. Now I'll try that in pitch. So I'll actually pitch backwards, and you can see that it becomes unstable at significant pitches when it gets a lot of airspeed. It is able to recover though if you raise the throttle and pitch the other way. And again, it loses a bit of stability when we're getting up to significant airspeeds. Alright, so the next thing is I am going to bring it down a little bit, and so then I will put it into fly-by-wire A mode. So what I'm going to do is just flick the switch to transition to fly-by-wire A. And there it is, transitioning to fixed wing mode, and it's flying fine in fixed wing mode. I'm using the exact gains out of one of the log files from Palm 369, so it seems to be flying pretty well. The gains aren't as high as I would normally set on a vehicle like this, so I'd call this a little bit sluggish, but it really is partly personal preference. And I would prefer it rolls a little bit faster, especially in pitch. It's a little bit sluggish in pitch, but it's, as I said, it's just the gains that that Palm 369 had on his own vehicle that I've kept the same ones. I have, however, set up an inverted flight channel, and it's going, when it flips over to inverted, it will take it a bit because it's a relatively slow roll. And there it is. All right, that's now flying inverted and back right way up again. Okay, now it's capable of flying along fairly fast. You can see it's got up to an airspeed of 75 kilometers an hour there at full throttle. And interesting, at full throttle there, it's drawing about 7.5 amps, which is similar to what it did in hover. Now I believe the number there in real flight, and that you'll see there's a little box up here showing the various statistics, and you can see that if I drop the throttle back a bit, sort of cruise along at half throttle, it's drawing about 3 or 4 amps, and that I believe is the per motor amperage, per motor current. All right, so what we'll do now is I'll just bring it down a little bit and run it along the runway and then transition to hover again. Okay, so it's coming in towards us, and I'll now transition. And there it is. You see it's a little bit wobbly during the transition. So it's sort of, I suspect it's just the gains are a little bit high, the D-gain perhaps, but I haven't yet tried changing the tuning. I've used the tuning based on what Palm 369 had done on his vehicle. Okay, so I will bring it down there now, and we can do a landing. And of course with TailSitters like this, the landing is the bit that is easiest to get wrong, because they so often tip over on their side. But let's see if I can, on the runway, do a neat landing without it tipping over. Bring it a little bit closer to the pilot and yaw it around a little bit. Nice view of Garfield there. And there we are. And it did decide to flip over. Damn it. Alright, so that definitely could be better. Let's get it back upright again. And so that's our cat TailSitter. And so it doesn't always flip over on landing, but if you have a look at videos of people flying the real thing, you'll find that an awful lot of them do. Let's see if I can do a flight without it flipping over on landing. So let's bring it down nice and gently. And it looks like we're going to make it this time. Indeed, that made it this time. Now, one of the issues with it on the ground is in the model that I've got here, I weren't able to really properly model the stands here. And so if we zoom in on this, then you'll see that the stands, the yellow lines here are the stands, and you can see that they come to a point here, whereas they're flat in the real one. And it's just because I haven't yet worked out how to adjust the physics model so that that correctly matches. And that does mean it's a little less stable. And the same, I had an issue with creating the physics model for the wingtip. So if I have a look at the winglets, then you'll see that the red lines there are the physics model for the winglet, and you see they come to a point there as well. And again, that's something that we can fix up. We just need to redefine the way the physics mapping and make it fit to the visual to get the correct shape there on those points. All right, so hope you've enjoyed this. I'll be popping this file up on the Siddle Models Git repository for other people to fly, and happy flying.